Welcome to the PrepNet, presented every Sunday at 6 p.m. Eastern Time on Talk2Me's Channel 14. Come join us to discuss everything about prepping and hear what others have done. All About Electricity, Part 21. Powering My DC Stuff. Last week, we covered how to use the stored power in your battery bank to power your AC equipment. This week, let's talk about powering 12 and 24 volt things directly from your battery bank. Why would I want to do this? The main reason is that running 12 and 24 volt items directly has no overhead, so you're not wasting any stored power from your battery bank. As you know, many of your rechargeable flashlights, portable power banks, and radios are charged by USB. Most, if not all, will come with a wall wart you plug into a 120-volt AC outlet to provide 5-volt USB power. If you plug that wall wart into your AC inverter, it will take more power from your battery bank to charge that item than it would if you could connect it directly to the batteries. Here is how I implemented that on my system, which I believe greatly enhanced it. Out of my battery protector, I run 24-volt DC power to a 30-amp DC circuit breaker and then to a blade fuse block. Each of the 3 central locations in my house uses one of the fused positions and has an 8-gauge wire providing 24 volts to a project box at those locations. Since my longest run is 66 feet, an 8-gauge wire can easily handle my max of 30 amps at 24 volts to another fuse block on the project box. That 24 volts runs many 24-volt USB power ports, so I can charge my phones, portable batteries, and radios without using my AC inverter. Another use for that 24 volts is that I run 24-volt RV-style LED lights in the 3 locations of the house. I have 1,000 to 1,500 lumen RV-style LED lights in each location. As an example, my living room dining room has 3 1,500 lumen RV-style LED lights. Each of the LED lights is equal to the light of a 100-watt incandescent bulb. However, an AC-style LED light only uses between 14 and 17 watts each. If I ran 3 100-watt incandescent lights, I would be using 300 watts of AC inverter power, plus the overhead of the inverter. But the 3 AC-style LED lights would use an average of 50 watts, plus the overhead of the inverter. That's an 85% power savings. For every 1 hour of running 3 100-watt incandescent bulbs, I can run 3 AC-style LED lights for 6 hours. But wait, there's more. The 3 RV-style 24-volt LED lights I have only averages 25 watts of draw without any AC inverter overhead, which means I can run them for 12 hours instead of the 6 hours for the AC-style LED lights. And that's a 92% power savings over the 3 100-watt incandescent lights. That alone sounds like a good reason to run 24-volt lines inside your house. Now to the 12-volt side. First, let's go back to the battery bank. I also have 12 volts available from my 24-volt system using a 24-volt to 12-volt 30-amp converter. The converter will step down the 24-volt battery bank voltage to 12 volts, and its overhead only consumes 25 milliamps or 0.7 watts. Not a big deal. In the basement, I have 12-volt power sockets, which are very close to the batteries, so voltage loss is not a problem. I am also powering some 12-volt LED lights that are no farther away than 10 feet, so again, voltage losses are not a problem. Now, back to my 3 locations in the house. If I ran 12 volts from the basement to these locations, the voltage loss would be too much. I use the 24 volts to each location to power another 24 volt to 12 volt 30 amp converter. In the living room, the 12 volts powers many 12 volt power sockets. These are used to power battery chargers that can charge many batteries at a time. Make sure when you buy your AA, AAA, 18650, or any other chargers that they can be powered from a 12-volt cigarette lighter socket to use this feature. In my ham shack, The 12 volts from the converter will also power my 100-watt ham HF radio, which draws a maximum of 20 amps at 12 volts. This will only draw 10 amps through the 24-volt line, so well under the maximum the 8-gauge wire can handle. There are many things you can power with 12 or 24-volt power that will increase the runtime of your battery bank, which is something you want in an emergency. Here is a quick and dirty example of the project box that is in each of those central locations. The 24 volts comes into the box via bullet connectors. Do not hardwire this connection. You want to be able to easily disconnect it. The 24 volts goes to a blade fuse block. All items to be powered must come through this fuse block. One of the fused positions goes to a 30-amp circuit breaker, which turns on the 24-volt to 12-volt converter, as you don't need to run the converter unless it is needed. The output of the DC to DC converter goes to another fuse block, which will power all your 12-volt loads. I also installed a DC meter so I could monitor my battery bank voltage and what was being taken out of the batteries from upstairs. I put a switch on this as the meter was not needed most of the time. Properly fuse your loads on the fuse block. Also, some equipment may have its own fuses, such as my ham HF radio does. This is fine and gives you extra protection. Be sure the length of wire from the 12-volt fuse block is less than 10 feet so you don't get unacceptable voltage losses. Next week, we'll have a listing of the All About Electricity series so you can see if you missed any of the topics. This series has been long, and you might have forgotten what we did cover. I think we'll start a new topic on All About Communications after that. If you have any questions about what we have discussed here tonight, please send your question to prepnetch14@gmail.com and enter question in the subject line.